When I introduce factorials, I actually start with the definition of N factorial. And I also tell students that this is not read as N, this is N factorial in math. So N factorial is defined as N times N minus 1 times N minus 2, so on and so forth, down to 3 times 2 times 1. Now most students, when they look at this, they don't know what it means. But as instructors, we need to get students to be able to start to read the language of mathematics. And mathematics is a language. So then I do a concrete example. I say, all right, so what is 5 factorial if we apply this? Well, we have N factorial, so N is 5. 1 less than 5 is 4. 2 less than 5 is 3, down to 2 times 1. And then we evaluate this and we get, what do we get here? 20 times 6 is 120. Okay, good. So then I do simplifying expressions that have factorials. So let's say we want to simplify let's do 6 factorial over 5 factorial. Okay, the first time I do this, I write the whole thing out. 6 factorial is 6 times 5, 4, 3, 2, 1. 5 factorial is 5, 4, 3, 2, 1. All right, and then I say, well, notice 6 factorial, in the expansion of 6 factorial, this right here is 5 factorial. So therefore, we could have written this as 6 times 5 factorial over 5 factorial. And the 5 factorials cancel and we're left with 6. Just like we see up here, this is 5 factorial. That cancels with that and we're left with 6. Then I continue and put in the n, and let's say we want to simplify. Let's do n factorial over n plus 2 factorial. Well, very similar to what we did before, n plus 2 factorial is n plus 2. 1 less than this is n plus 1. 1 less than, or 2 less than this is n, and then we have n minus 1, and that part is n factorial. Yeah? So this is n plus 2 times n plus 1 times n minus 1, n minus 2. But that n minus 1, n minus 2 is n factorial, and these cancel, and we need to remember when they cancel, there's really 1s. So we're left with 1 over n plus 2 times n plus 1. And being able to do this type of factoring becomes pretty critical in calculus, particularly calculus 2.